Hello, so good day everyone. My name is Leo Evan Bendijo, and we are the group 10 of the MTEC 102, Fridays and Saturdays 9 a.m. to 10:30 a.m. So our topic is about radar. So radar is an acronym for radio detection and ranging. So it is a system that uses radio waves para to determine range, bearing of a ship, usually sa mga merchant ships or all ships na need in order to detect a mga bearings and angles of others. So along with me is my teammates, Mr. Bulawan, Mr. Montehermoso, and last but not the least, Mr. Ogoc. So this presentation will address the background of IMO position on maritime security, the measures required by SOLAS and the ISPS code, the responsibilities of governments, ports, and companies, and some implementation strategies. So new technologies of radar or radio detection and ranging become available to merchant shipping with the end of hostilities in 1945, way back 1945. Radar on merchant ships was initially installed for commercial purposes. So way back, for commercial purposes ran radar on ferries and to maintain better schedules in fog. And large fishing vessels, radar was treated with a great suspicion by the mariners. And so with improving technology and after, since nagka-high-tech, sometimes the use of radar for safety purposes was recognized misinterpretation of radar information and had not resulted in any reduction of number of serious collisions at sea. So niabot sa time na misinterpret radar information, which resulted in any reduction of number of serious collision. International Conference of Safety of Life at Sea, or the SOLAS, in 1960 revised the international regulations for preventing collision at sea by adding rules to take account of the use of radar and recommendations on the use of radar information as an aid to avoiding collisions. So radar is an aid also to avoid such collisions at sea. So ako sa SOLAS, nag-implement sila or nag-revise and regulations to preventing collisions at sea. Nag-add sila og rules in account to the use of radar and some recommendations. The International Conference on Safety of Life at Sea in 1974 adopted provisions to the SOLAS Convention, making radar a mandatory carriage. So yeah, by the time na well-known na radar, mandatory carriage of it is a requirement for merchant ships in a phase of program starting in 1980, which finally completed in year 2002. So SOLAS requirements. So all merchant ships of 300 gross tonnage and over now shall carry a radar, and many carry two. So IMO adopted performance standards for marine radars, which are used in integration with other navigational equipment required to carry on board ships. So yung merchant ships or yung barko is 300 gross tonnage, so you will carry one radar. If more than that, many carry two, as per adopted performance standards for marine radars. So mga requirements on your ships: an automatic target tracking aid, or the tracking aid. ARPA means these are required also on your ships, and also a aid to prevent collision at sea. In ARPA, or the automatic radar plotting aid, this can calculate tracks and course, speed of the vessel, other vessel. AIS, or the automatic identification system. Like this one is also a tracking system na mag-use og transceivers to determine others, like may bawaan og unsay name sa ship. And next, the ACDIS, also a system, tracking system. Like mura na siya og paper chart, pero electronic chart that display information system. Since high-tech kita, geographic information system, this is to facilitate efficient navigation. And last but not least, and also a GNSS. GNSS is a global navigation satellite. So GNSS and GPS are almost are likely the same, since they are one of the main satellites na mag-provides of such data, like mag-transmit of positioning and timing, and also others. And that would be all on my part. Thank you.
Is radar such as valuable tool. The master and watchkeepers have confidence in information radar provides because its operation is ship-based. This means that radar operates on detecting that the objects that surround ship. It is being operated, therefore it gives a sense of security that the information it is providing is the current situation around the ship. It is on board and not other. So the second is, it is not reliant on third-party sources. So the radar works on its own and monitored by the ship masters and watchkeeper. Its operation is not and cannot be controlled by anyone outside the ship premises. Therefore, personnel are more confident that nobody can sabotage the radar operation except for themselves. It has proven track record. So all over the world, radar is widely known to help on presenting collision and aiding navigation. It has been proven that it functions accurately and real time. That is why it is a must-have in all ship, planes, and etc. Radar is useful with SARTs when engaged in search and rescue. So, in times of distress, SART or search and rescue transponder serve as signalman. It has transmitter and receiver that enables it to transmit as well as receive radio signals. So these signals coming from SART can be picked up by the radar, therefore aiding the search and rescue of a distressed ship. So in short, in its display, radar offers the watchkeeper the physical reality of all targets relative to the ship. It therefore aids the watchkeeper and helps in decision making for both navigation and collision avoidance. So, collision avoidance. Early action is required to avoid a close quarter situation. Therefore, early identification of closing targets is essential. Watchkeeping officer needs to be competent in the use of radar and are trained in its use and application of the ARPA. So, we all know that radar detects and display objects around the ship. Therefore, together with good decision making, it helps in avoiding collision and accidents. So, some IMO requirements. Maximum emergency stopping distance from full speed of the ship should not be more than 15 ship lengths. So, emergency turns radius of the ship should not be more than 2.5 lengths. Ship's parameters: speed up to 25 knots, length largest container ship 335 meters, and Cape-size bulker 300 meters, Panamax 220 to 230 meters. Ship's parameters: emergency stopping 3.3 kilometers to 5 kilometers or 1.8 nautical mile to 2.7 nautical mile, and emergency turning radius 550 meters to 840 meters or 0.3 nautical miles to 0.45 nautical miles. Displacement weights 100,000 to 250 tons. Practical requirements. To start plotting targets and determining their course and speed, the target is between 8 and 10 nautical miles off. So, the officer in charge on radar monitoring must determine the course and distance of the nearby or approaching ship or object when it is inside 8 to 10 nautical mile distance. So, navigation. Radar gives accurate information on distance from charted features and assists in maintaining the ship course. So, radar will normally show us 60-meter high landmass at a range of 20 miles. This is considered by seafarer as minimum requirements. So, this is the illustration of a radar.
Determinations of targets from a watchkeeper's perspective. So, to be able to distinguish a tug from its tow at sea at 12 miles range, approaching a rig on a supply vessel, to clearly identify the standby boat from a rig at 6 miles range, to be able to distinguish the anchor pennant buoys of a semi-submersible rig at 3 miles range. So, next is the example of a tug vessel, and this is a supplier vessel and a standby vessel. So, range. The radar system should be capable of displaying 2 points targets on the same bearing, separated by 40 meters in range as to distinct object. And bearing. The radar system should be capable of displaying 2-point target on the same range separated by 2.5 degrees in bearing as the distinct object. So here is the example or the picture. So we have a gyro of 142.1 degrees and our range is 0.75 nautical miles. And our true course is 217.9 degrees. So that's next. So navigation. Radar greatly assists navigation during poor visibility or in a fog, if there are so much fog. So, pilots rely on radar at close range and reduce visibility to pass buoys and beacons.
Navigation. Radar greatly assess navigation during poor visibility. Pilots rely on radar at close range and reduce visibility to pass buoys and beacons. So, radar during poor visibility when navigation, it is very critical task na siya. So, radar should be used to identify targets then before they get too close, because radar can scan short range and long range. So, pilots rely on radar at short range. So, in order to pass safety or to navigate safely. So as you can see, this picture is a radar. As you can see, the ship heading is 149.4. Then the ship speed is 2.8 knots. Then the range is 6 nautical miles. So as you can see, the violet represent buoys and beacons. Then the word X-band is discrimination or good visibility and track performance. So for ang example ani ang mga boats or mga small boats. Then na po siya nakabutang S-band or to ensure that the target detection capabilities are maintained in varying and adverse condition in fog, rain, and sea clutter. So, ang example ani kay mga meteorological weather. So, muna ang S-band. Then, this picture, as you can see, the gain is full. So, meaning, gain can affect the receiver and not to display as the variance does. So, if ang radar detects sa targets, ma-interference gikan na siya sa sea or mga sea echo. Then, so resolution MCC 192 or to 79 or resolution Maritime Safety Committee 192-79. This adoption on revised performance standards for radar equipment. So na-adapt ni siya on December 6, 2004. So minimum range with own ship at zero speed, antenna height of 15 meters above of the sea, and in calm condition, the navigation in table 2 should be detected at a horizontal range of 4 meters from the antenna position and up range of 1 nautical miles, changing the setting of control function other than the range scale selector. So, engineering terms, resolution ITO RM 1313, power 3070 kilowatts, horizontal beam width 0.75-4 degrees, pulse width 0.03-1.2, microsec PRF 400-375, and HZ noise figure 3-8 dB or decibel. So meaning decibel is to measurement the sound level. So it is a unit measurement corresponding to 1/10 of bell. Then antenne. So pitch 3 degrees. So meaning pitch is to up and down move of the ship from port to stern. Then roll 25 degrees. So roll means port to starboard inclination. Then ang yaw 5 degrees is side to side move of the ship or side to side from bow to stern of the ship. Then so vertical beam width 20-30 degrees. So vertical beam width, the main reason for vertical beam width is to ensure the ability display of a target of a pitching. So meaning even though the ship is pitching or rolling, nagtuya-tuya, then the vertical beam width is magamit na siya to ensure gihapon nga masakto ang target. Then X3 band radar or X band radar, then Shira band radar or S band radar. So ang kalainan nila duha is X-ray band radar is for like mga detecting like mga boats and small boats, while the Shira band radar mga meteorological weather like mga rain, then mga sea clutter. So that's all. Thank you for watching. I hope you learned something for our presentation. Thank you.